So it says find the odds against rolling a 3 on one roll of a normal 6-sided die. So odds against, remember we're going to want failure to successes. So if we look at 3 as being a success on a 6-sided die, how many failures are there and how many successes? Well, that would mean there were 5 failures and only 1 success because there's 1 3. So the odds against rolling a 3 is 5 to 1. In number 2, it says 7 out of every 9 people who apply to Stanford get rejected. So if you were to apply, what would the odds against being rejected? So this one's kind of weird. We want odds against, which is still failure to success. But remember, this is talking about the event, and here our event is being rejected. So we have to think if you get rejected, that is a successful event. So if 7 out of 9 get rejected, okay, we can think of this as being the success over success plus failure. So that means 7 people get rejected. That comes over here. And how many people are left that get accepted? It would only be 2 because we have a total of 9 people. All right, in number 3, it says 2% of the United States population is born gifted with an IQ greater than 130. So find the odds in favor of being born gifted. So in favor is going to be success to failure. Now here, that 2%, that's really written as a probability. So we could also think of that as being 2 in 100 or 1 in 50. So what that means is, if we're comparing this to success over success plus failure, it means that we have 1 success and 49 failures. Okay, so our success to failure ratio would be 1 to 49. So this would be the odds in favor of being born gifted. All right, for number 4, 23 out of 27 students passed the Chapter 12 test. Find the odds in favor of not passing the test. So odds in favor are success to failure. But we're looking for the success of not passing. So how many don't pass? Well, 23 out of 27 pass, so that means 4 people don't pass and 23 people do pass. Okay, so we really have to think here that success is not passing and failure is passing. All right, number 5, if the odds against winning the game are 9 to 2, find the probability of winning the game. So odds against are failures to successes, and that we know is 9 to 2. Now remember, the probability of winning is going to be the number of successes, which is 2, over the total of success plus failure. So 2 plus 9, and here we're going to get 2 in 11. Okay, so just take your odds, identify which one is success and failure, and put the success over the sum of success and failure. All right, for number 6, if the odds in favor of winning are 3 to 7, find the probability of losing. So in favor means success to failure, and that's 3 to 7. And here, success means that you win. So it's going to be the number of wins to the number of losses. And we want to find the probability of losing the race. So in this case, we don't think necessarily of success and failure, but we want to find the probability of losing. So losing is our failure, so how many times do we lose? It would be 7. Over the total number of times we tried, which would be 3 plus 7. And so this is going to be 7 out of 11. Okay, so this is basically what we're trying to do with all of the odds against, odds and favors, and probabilities. You're going to have to be very careful that you outline what you have, what type of odds you have, and then what the event is, and then make sure you translate it correctly into the problem. So sometimes they're going to switch what the event is between the odds and the probabilities.